Welcome to our presentation, A Better Open Source Database Platform. In this presentation, we will describe a different approach to database architecture. Rather than viewing a database as a single application, we view it as a platform that may incorporate multiple database products and other open source tools that allow the platform to better support all your database needs. Undoubtedly, you already have some type of operational database supporting your application. Probably that database is a traditional row block design. Oracle, SQL Server, DB2 are common COTS databases. Postgres and MySQL are common open source databases. The problem is that these are only one type of database. There may be other types that better serve your other use cases. NoSQL databases is commonly used for unstructured data, but is also a good option for storing archival data no longer needed in your operational database. Examples of NoSQL databases include MongoDB, Couchbase, and the Hadoop-based storage devices. Columnar databases are better at supporting BI tools and the dynamic queries that come out of these systems. Columnar databases include Amazon's Redshift, MariaDB AX, Postgres with the Columnar plugin. The large vendors include hybrid columnar databases in their product portfolio, such as Oracle's Exadata, and have buffer-based solutions like Oracle's in-memory option or DB2 Blue. In this presentation, we are going to explore the differences between the traditional row block database and a columnar database, as well as discuss when you would want to use one over the other. If you are going to use multiple databases in an architecture, you must keep them in sync through a change data capture mechanism. You may not need a special tool for this since many databases like SQL Server have that ability built in. MariaDB provides MaxScale, which can serve this purpose. We have used Talon and Debezium to perform this operation as well. You will also need a database proxy or query router tool to provide a single access point for all your queries. Based upon the nature of the query, the SQL is run against the optimal database. MariaDB's MaxScale serves this purposes. Other solutions include PG Bouncer, which is a Postgres plugin, and ScaleArc. You can build a platform from a variety of databases and integration tools, but you should focus on databases that can scale horizontally. Databases can always scale vertically, meaning you increase the size of the underlying server to give the database more power. Horizontal scalability is preferable since it doesn't require an outage. Horizontal scalability means adding an additional server to the cluster to give the platform more power. You should also select a database that works well with Kubernetes, since this will support the horizontal scaling, the quality of service provided by Kubernetes, and with the new Kubernetes operators makes the database self-healing. Let's look at a columnar database to understand why you'd want to set up a multi-database platform. Both the traditional database and the columnar database store data in blocks. With a traditional database, the entire record is written to the block, and the block is filled up with as many records as will fit. Blocks are added until the entire table is stored. With a columnar database, a block is dedicated to one column of the table. A block is filled with as many records as will fit, but only for that specific column. Blocks are added until the entire table is stored. Performance is all about how many blocks you must read. Let's take the case of a database with about 10 million records that averages about 500 bytes per record. It will take about 625,000 blocks or 5 gigabytes to hold all the data. When you run this query to select gender count from traffic tickets, you must query the entire database, reading every block and every byte. But because gender is only one character, it then throws away more than 99% of the data it just read. With the columnar database, it just reads the blocks associated with gender and throws nothing away. Rather than reading 625,000 blocks, it only reads a couple thousand blocks, which makes the query often hundreds of times faster. As you add columns to the query, the performance impact to the columnar database is often linear since you are reading more blocks with each column. Even though there are no indexes in the columnar database, there is a similar performance benefit when a specific predicate is defined, such as this query for one state. But for the columnar database, the benefit is lost when the select line includes every column in the table, since that means more blocks to read. With updates, the traditional database wins. If you update one record in a traditional database, that means one block is updated. With a columnar database, one block for every column in the table must be updated. Every type of database has its own benefits and drawbacks, which is why a platform requires more than one type of database. The query router understands these differences and will redirect queries to the best database for the operation. Updates and full table operations will go to the traditional database, while ad hoc queries will be directed to the columnar database. Thank you for watching our presentation. If you would like additional information, you can contact us using the information currently on the screen.